Let's see how to make PMOS common source amplifier with PMOS current source load. So initially we need to create the new project. Okay, I just created the 2 times. I'm just closing this, and we need to insert the PMOS. Okay, so PMOS, PMOS, and this is the discrete PMOS. So this we need to insert, and this is for the main amplification, and another one is for the PMOS current source load. So in PMOS, okay, let's just name its source and the drain. So in PMOS, always remember source, and this is the gate, and this is the drain. In NMOS, it is drain, gate, and the source. So this is the source, and okay, this remaining thing. So we can just remember these things. So it's the source is the drain, and this is the gate, and this is the base. So now we need the two, that means the three sources. So for that I just need to press the V button, and here this is for the input, that is the sine wave we are providing for this one, and here we need to for this a current source PMOS, that's why we even need this, and another one is the VDS. Okay, so this is our VDS. So we just name these. This is our VDS, and this is our V. Okay, so VGS, and this is our VB. Now we need to, instead of this register, I connected this PMOS. So now we need to connect these things. So this is for the VGS, that means it is between the gate and the source. So this I'm connecting to the gate. Okay, so this, since it is a PMOS, it has a here the gate, that one we need to give as a negative voltage. So because the PMOS means here this will be going to have the P channel, and here in order to attract the that means the holes, we need to create the negative, more negative potential on this gate. That's why we are connecting the negative voltage for this gate by using this source. So this is the VGS, and here uh, this one has to be connected to the source. So I'm just connecting the ground here, and so that's why I'm connecting the source even to the ground, or else we can just connect like this. So instead of creating the ground here, so what I will do means I will just connect as per VGS. So this has to be connected between the gate and the source, and from this one I need to give it to the VDS. So here this has to be connected to here, and so this is the base, and that has to be connected here, and this to, okay, from here to here, and this one we need to connect, we will make this base to connect to the same potential, and this one connect, we need to connect to VB, and here we need to connect this to the ground, and even so here we need to connect this to the ground, otherwise this will be becomes the floating. That's why I'm just connecting the ground here. So now we just connect these things from here to here, and from here to here. So now let's feed the circuit to the screen. Okay, now we have all these things, and we need to set the input, that is the sine wave, that we just call this as a sine wave, and DC offset. So we need to maintain this in a saturation region. So it has to be greater than 0.6. I'm just giving 0.72. Okay, so 0.72, and this amplitude, okay, 1 millivolt, and the frequency of 2k. Let's say this has a frequency of the 2k, and let's say this is a minus 0.98 or anything. You can just try these values, and you can just set it at what value you are getting the good gain. So I just set this as a minus 0.98. The gain is very less for this circuit, around only the 2 gain of 2 I am getting, but you can play with these L and W, and we can just get these values. So here I just need to give 1.88. So here the main thing here, instead of this register we are replacing that with the current source PMOS load. Okay, here instead of this RL we are replacing this load. So then this one we just set this as a 1U and 20U, and here let's set this to 1U and 100U. Okay, now these things are set, and this one okay, and this one. Now let's simulate the circuit and let's see. So stop time after 10 milliseconds, and here 0, and here maximum step size of 10. So now we just see the circuit. Okay, so now if you want to check the output here, okay, we are getting something like this. So VDS, okay, so these things minus 0.98, and this one 1M, and okay, now let's change these W by L. Okay, so this is 1U and 100U, and this 1U and 20U. Okay, this is proper. And now what we will do means we need to correct these waveforms. So if we see the input, then it is somewhat like this. So we just increase its tolerance value. Once we just increase, and we will just check it whether we are getting, and here also in the output. So output we need to get like, okay, I forgot to mention one thing. So we just change that relative tolerance to as it is, that the previous values. That's to just I need to check whether the input is like it is at the same 0.0025, whether it's giving the proper the input and the output or not. So I just forgot to mention these MOSFET model parameters. So for that I need to write dot model, and here we use the PMOS. So PMOS, and we need to have this kp equals to 200U, and this VTO. Okay, so 200U, and VTO equals to minus 0.6. So this one we just need to have here, and we just run the circuit and we just see the output now. So okay, now it's almost from okay, so this is our input, and we can see from here our input and the output is okay. We'll just show this again. So this is what our input, I think so okay, yeah, this is what our input, and this is from minus 7 and 19.8 to minus 7. Okay, from here. Okay, so minus 720 to minus 719, that is the 1 millivolt input. And if we see the output here, we can just see it is slightly get amplified, but it is very less from minus 100.4. okay, so from here and minus 100.2 till to 6, then here it will be 1, and that is around 1.5. it's very less. Okay, but we can just play with these values, and we can even increase the gain. um, for increasing the gain and these things, we will see some of the other circuits, but here the main thing we just replaced by these things. I think you understood how to construct these kinds of circuits. Thank you.